All right, today we're going to look at the proof that diagonals of a rectangle are congruent. Let's consider a rectangle ABCD. We wish to show that AD, the length of AD, is equal to the length of BC. Rectangles have two properties. Opposite sides are congruent, which means that AB is the same as CD, and AC is congruent to BD. And the second one is all angles are 90 degrees. So all four of these angles are 90 degrees. What I'm going to do is we're going to separate this rectangle into two right triangles. Let's consider triangle ACD and triangle BDC. And if we can show that BC is equal to AD, then we have proven what we need to prove. All right, so when we break this into two right triangles, we know that AC is congruent to BD because of the property of a rectangle. And we know that CD is congruent to itself because of the reflexive property. Remember, it comes from that same rectangle. There's two ways to go about this. Let's look at Pythagorean theorem, and then I'll look at the congruence triangles. If you use Pythagorean theorem, we know that the hypotenuse, which is AD, the hypotenuse squared, is equal to the sum of the square of the legs. So you're going to have CD squared and AC squared. And likewise, in the other triangle, you have the hypotenuse is going to be BC. And that's going to equal to the sum of the square of the legs. That's also CD squared plus BD squared. Okay? This is true because of the Pythagorean theorem. That works for all right triangles. But what I want to show you is this. I can set these two expressions equal to each other. If you notice that CDs will cancel each other out, and that just leaves you with AC squared equal to BD squared, which will leave you with AC is equal to BD. There's another method I'd like to show you. Now we know these are two right triangles because we're dealing with a rectangle. We know that AC is congruent to BD because opposite sides of a rectangle are congruent. And CD is equal to itself. So I can use side, angle, side, and say that AD is equal to BC. In this case, because we have a one-to-one proportion here, because it comes from the same rectangle. In general, that's not true. Sometimes you have 2-to-1, 3-to-1. In this case, it's 1-to-1, because it comes from the same rectangle. Therefore, AD equals BC, thus proving the diagonals of rectangles are congruent.